Good afternoon, everyone. I'm Pauline Gabat, and I'm going to show you another example of analysis of variance and how to perform it in Excel. For example 2, given was the arithmetic test course of 18 students, consists of boys and girls of different ages. We have here the boys and girls of 10 years old, boys and girls of 11 years old, and boys and girls of 12 years old. And we want to determine whether the gender or age group or both gender and age group impact the test scores. So we have two factors of the independent variables here, the gender and age. For the step 1, state the hypothesis. The hypothesis for the interaction effect is the null hypothesis is there is no interaction effect between the gender and age of the students in their test scores, while the alternative hypothesis is there is an interaction effect between the gender and age of the students in their test scores. For the first factor, which is the gender, the null hypothesis is there is no difference in the means of the student score of two gender groups. The alternative hypothesis is there is a difference in the means of the student score of the two gender groups. For the second factor, which is age, the null hypothesis is there is no difference in the means of the student score of the three age groups. And the alternative hypothesis is there is a difference in the means of the student score of the three age groups. Second step is find the critical value for each f-test using alpha is equal to 0.05. For the factor A, or the gender, the degrees of freedom numerator is equal to A minus 1. A here refers to the number of levels of first factor or gender. So in gender, we have the girls and boys. So we have two levels. 2 minus 1 is equal to 1. So the degrees of freedom for the factor A is equal to 1. Next is for the factor B or the age. The degrees of freedom is equal to B minus 1 where B is equal to the number of level of the second factor. For the second factor, we have 3 levels, the 10, 11, and 12 years old. So 3 minus 1 is equal to 2. Next is for the interaction of factor A and factor B. We have the formula A minus 1 multiplied by B minus 1. So 2 minus 1 multiplied by 3 minus 1 is equal to 2. And lastly, for the error, we have the formula AB multiplied by n minus 1, where n is equal to the number of data values per group. In this case, we have 3 sample size per group. So 2 times 3 multiplied by 3 minus 1 is equal to 12. So the degrees of freedom for the within or the error is equal to 12. So now let's find the critical values in F distribution table for alpha is equal to 0.05. Critical value is equal to F, quantity DFN, DFD, where the DFN is equal to the degrees of freedom of each data and the DFD it refers to the degrees of freedom of within or inward. For the first factor, we have F, 1, and 12. 1 is the degrees of freedom of the first factor, and 12 the degrees of freedom within. For the second factor, we have F, 2, and 12, and for the both factors, we have F is equal to 2 and 12. So next, we're going to locate it in the F distribution table for alpha is equal to 0.05. For factor A, our DFN or degrees of freedom numerator is equal to 1 and our DFD or the degrees of freedom for denominator is equal to 12. Then, titingnan lang sa table kung saan nag-meet yung dalawang degrees of freedom. Degrees of freedom is equal to 1 and degrees of freedom is equal to 12. Then, the critical value for factor A is equal to 4.75. Next is for factor B and interaction. which has the same degrees of freedom for numerator and degrees of freedom denominator. And our critical value for fraction is equal to 3.89. Then let's plot it in the table. Step 3. Complete the ANOVA summary table to get the test values. But first, let's construct a mean table that we can use in getting the sum of square in the ANOVA summary table. So the mean for boys of 10 years old, we have 6. The mean for the 11 years old boys is 7. And the mean for 12 years old boys is 10. For the girls, we have girls of 10 years old is equal to 7, girls of 11 years old is equal to 10, and girls of 12 years old is equal to 14. Then we must get the total average of the mean of per level or per group. For 10 years old, we have 6.5. 11 years old, the mean is 8.5. For the 12 years old, we have 12. The total average of the scores for the boys is 7.67, and the total average scores of the girls is equal to 10.33, and their grand mean is equal to 9. Now let's complete the ANOVA summary table. Now let's solve for the sum of square. For the sum of square of first factor or the gender, we have the formula summation of n sub I multiplied by mean sub I minus the grand mean raised to the power of 2, where n sub I is the sample size per level of first factor. So in the gender group, we have 9 boys and 9 girls, and mean sub I is equal to the total mean per level of the first factor, which is these values. So the summation of the first factor, or the sum of square the first factor, is equal to 9 times 7.67 minus 9 squared plus 9 multiplied by 10.33 minus 9 squared is equal to 32. For the sum of square of second factor, we have the formula summation of n sub I multiplied by mean sub I minus grand mean square, where n sub I is equal to the sample size per level of second factor. And in age group, we have 6 10 years old students, 6 11 years old students, and 6 12 years old students. And the mean sub I is equal to the total mean of level of second factor. So the sum of square of second factor is equal to the 6 times 6.5 minus 9 squared plus 6 multiplied by 8.5 minus 9 squared plus 6 multiplied by 12 minus 9 squared is equal to 93. For the sum of squares within or error, we have the formula summation of scores minus mean square. So this is the scores of the boys and girls, and we're going to subtract it in their respective mean. Then get the summation. Now the sum of squares within or error is equal to 68. Then for the total sum of square, we can get that by using the formula summation of scores minus the grand mean square. First is get the difference of scores and grand mean, then square it and get the sum of all values. So the total sum of squares is equal to 200. Last is the sum of square of interaction. The formula for the sum of square interaction is equal to sum of square total minus the sum of square of factor A minus the sum of square of factor B minus the sum of square within. So 200 minus 32 minus 93 minus 68 is equal to 7. The sum of square of interaction is equal to 7. Next is the mean square. Mean square is equal to sum of square divided by the degrees of the. For factor A, we have 32 divided by 1 is equal to 32. For factor B, 93 divided by 2 is equal to 46.50. For within our error, we have 68 divided by 12 is equal to 5.67. And for both factors or interaction, we have 7 divided by 2 is equal to 3.5. Next is the F-test or the F-score. F-score is equal to mean square divided by the mean square of within or error. For factor A, we have 32 divided by 5.67. 32 is the mean square of the first factor and the 5.67 is the mean square of within or error. So for factor A, we have 5.64. Next, for factor B, we have 46.50, the mean square of second factor, and 5.67, the mean square of within or error. For factor B, we have 8.20. And for both factors, we have 3.5 divided by 5.67 is equal to 0.62. Step 4. Make the decision. For the factor A or gender, our critical values is 4.75 and our F-score is equal to 5.64. And we can see that the F-score falls on the critical region, so our decision for this is to reject the null hypothesis. For the second factor, which is age, our critical value is equal to 3.89 and the F-score is equal to 8.20. We can see that the critical value is less than 8.20, which is the F-test. So our decision here is to reject the null hypothesis. And for the interaction, the critical value is equal to 3.89 and the F-test is equal to 0.62. We can see that it does not fall in the critical region. So the decision is to not reject the null hypothesis. Step 5. Summarize the results. Since we reject the null hypothesis for the main effects, hence we can conclude that there is a difference in the means of the student score with respect to gender, and there is a difference in the means of the student score with respect to age. While for the interaction effect, we failed to reject the null hypothesis. So, we can conclude that the gender and age has no interaction effect on student score in arithmetic test. Next is, we will see if we will get the same results using Excel.